binary basics. The easiest path to understanding zeros and ones. Base-2, expanded form. When we look at decimal numbers in expanded form, we saw how each digit could be stretched out to show the value it represents in its place. The same idea applies perfectly to binary, except we use powers of 2 instead of powers of 10. With expanded form, we can break apart a binary number, so we can see exactly how much each bit is really worth in the grand total. It's like putting binary under a magnifying glass, revealing the contribution of every single binary bit. In binary, every digit sits in a specific position, each with its own value. Unlike decimal, which uses ones, tens, hundreds, and so on, binary's place values go up by multiples of 2. When you write a number like 1001, each position matters. The leftmost one is located in the 8's place. The 0 beside it is in the 4's place. The next 0 is in the 2's place. And the last one is in the 1's place. Expanded form means taking the ones and adding up the value of the positions where they appear. If a digit is 0, we can skip it. With binary, zeros still act as placeholders, but they do not contribute to the total value of the number. To continue increasing our understanding, let's walk through a slightly different example together, with the binary number 1011. First, we look at the place values lined up underneath. From left to right, they are 8, 4, 2, and 1. Now we can use substitution to replace each one with its place value. Working from left to right, the first one is in the 8's place, so we make that an 8. There is a 0 in the 4's place, so we will just skip that for now. The next one is in the 2's place, so we make that a 2. And the last one is in the 1's place, so we will leave that as a 1. For expanded form, we will add up these values. So from left to right, we will add 8 plus 0 plus 2 plus 1. This gives us a total of 11. That means 1011 in binary has a decimal equivalent of 11. Using expanded form is especially helpful when you are learning about place value because it forces you to slow down and consider what each digit means. Here we can look at binary and expanded form using 2 more variants. Using the same binary number, 1011, we will once again start by lining up the place values under each digit. From left to right, they are 8, 4, 2, and 1. Matching each digit to its place value, we can see that we have 1 8, 0 4s, 1 2, and 1 1. We could also write this as 1 times 8 plus 0 times 4 plus 1 times 2 plus 1 times 1. No matter which way you choose to apply expanded form to this binary number, 11 will always be its decimal equivalent. One thing that's especially neat about binary is how direct the process is. In a way, it is even easier than decimal. Whenever you see a 1 in any place, you can simply substitute that place value right into your total. That's because in binary, every time you see a 1, it just means 1 times its place value. And every time you see a 0, it means 0 times its place value. From there, it is as simple as adding up all the place values wherever there's a 1. This direct substitution makes binary much easier to handle than it might first appear, and with a little practice, you will be able to look at a string of zeros and ones, and instantly know which values to add together. So next time you see a binary number, try stretching it out into expanded form. It's an easy way to double-check your work and see the real weight each binary digit carries. Learning this method will also prepare you for what I have planned in the next lesson, which is binary and exponential form. That is when you will see how each place value can be written as a power of 2, making big numbers even easier to handle. Thank you for watching. Subscribe for more great content.